To turn the microphone on in order for me to record. All right, here we go. Systems of linear inequalities is what our topic is here. And again, the inequality piece got taken out of Algebra 2. And that's why this may be a little bit different for some of y'all, maybe first time seeing it since Algebra 1 is what it might have been. And so as we look at, when we're going to be dealing with linear and nonlinear, we're dealing with one equation on each of these ones at the moment. Then eventually we get to do systems of inequalities here later on in the lesson. So I'm going to give you some ground rules of how could you go about doing this. But instead of having an equal sign, we have these inequality symbols. And so one thing I want to make a note is inequality symbols mean we shade part of the graph. And any ordered pair in the shaded zone is a solution. When you're dealing with like systems of inequalities or just inequalities, where you just have one and you're graphing on a two-dimensional surface, XY grid, you're going to be shading part of the graph. And any ordered pair that is in the shaded zone is technically a solution. Whereas when we were graphing just a line, it was any ordered pair on the line is a solution. When we did systems of equations last Thursday, where we said this line touches this line, well, when they touched once, that was the one unique solution that balanced both equations. Now we open it up with the inequalities that there's more than one solution. We're just narrowing down the range of zones of the shaded zone of what's a solution to, in this case, these two problems. Later on, we get to merge two graphs together saying, hey, this is what they have in common. This is the only solution zone. Right now, when you only give them one equation, half the graph is a solution, the other half the graph is not a solution. Okay, it's more or less what happens. When you start putting another, sorry, that's my Wi-Fi speaker turning off, my Bluetooth speaker. When you start putting more than one equation in here, then you start narrowing it down to maybe 1/4 of your overall picture is a solution zone. 3/4 of it is not. Okay, so in case you didn't know graphing inequalities, we know what number lines are, but again, this stuff kind of got taken out of a lot of math courses in Algebra 2, especially. So here's what I'm going to suggest that we do for steps. First thing we need to do is we need to graph the equation. So again, however you want to graph, if you want to use x and y intercepts to graph, if you want to use slope-intercept form to graph, whatever you want to do, we got to graph the equation in our first step. Second step, we need to draw the appropriate line. I'm going to say type of line. Type of line. You're either going to do a solid line or a dashed. And I'm going to explain the difference, how you know each one here in a moment. So you got two choices of lines to draw, either a solid or a dashed line. And then after that, step number 3, shade above or below the line. Now, those are 3 generic steps. All right, they can get more specific, but they're pretty much generic there. Some have some extra little sub-steps, but that's more or less what we got to do. Is first thing we got to do is we got to get ready to graph the equations. As I go to draw the line, I need to draw either a solid line or a dashed line. And then I got to shade above or below. And I'm going to tell you when do you know you do which here in a moment. Okay, Jonas.
Do we need a calculator?
I'm going to show you how to do it by hand. Okay? Because it's hard to do some of these, like B, it's hard to graph it on the TI-84. All right, so over here to the right-hand side, let's write a couple notes here. We have 4 inequality symbols. We have and now here's I guess as we get ready to say it. As I start pronouncing these, we're gonna put y on the left-hand side. All right, so like y is less than or equal to. Then we have y is greater than, and then y is greater than or equal to. And technically there's a 5th one, what's the other symbol? Not equal to. All right, there's technically 5 inequalities. So whenever we and again, it's important to understand, okay, where is the y? Because when we go to shade, we have to basically look at it and say, okay, how does the inequality open up in relation to where the y is? Because that lets me know if I'm shading above or below, is what that does. Okay, so right now I have it rigged to have the y on the left-hand side so that I can say y is less than as we do things. Now, if I put the y on the right-hand side of some of these symbols, it changes the opposite sign. Okay, so how many of your teachers always taught you to keep the y on the left when you solved it for slope-intercept form? All right, which teacher?
I feel like that was in 8th grade.
Okay, there you go. And that's what sometimes we did in the younger years. Is like, hey, always solve for slope-intercept form and have y on the left. And then that was a way to kind of get you started. Once you got up into high school, we basically said, hey, it really doesn't matter. You just learn to read it the opposite way. Okay, but when we wanted to narrow it down, when your minds were still moldable and stuff, and you know, sometimes you're too scattered, we're like, hey, this is what we want to do. Always do it to where y's on the left. We narrowed down the freedom. So with this in mind, the first one we shade below a dashed line. The inequalities, the equal sign on the inequality indicates whether the line is dashed or solid. So, since I'm saying less than, then I am shading below. Less than means below. So here we would say we shade below a solid line. Next one down says y is greater, so we shade above a dashed line. Because again, there's no bar. The bar indicates that it's a solid line. So a dashed line. And then next one we shade above a solid line. And the last one we shade above and below a dashed line. We don't see those used that often, but that's basically what it is. When you have, if you're asked to graph a not equal to one, then basically you're putting roughly where is the dashed line, taking it from slope-intercept form, where would the line be? Well, let me make it dashed. And then I'm shading above and below because it's basically indicating I'm everything but this line is a solution. Okay? Again, we don't see that one that often, but it can happen. So I'm assuming this is new. Is that new for a lot of you?
I mean, I'd say so.
All right. If it's not new, the only time you would have had it would have been Algebra 1. Which was how long ago for most of you? Yeah, a long time. Okay. So, refer back to that chart. Okay, refer back to it. You can probably consolidate it different ways and stuff, and I'll show you how I usually have kids do it. So, now, the only thing I would do right now, like as I look at problem A, The only thing I would do right now is make an indicator that this is a solid line. When I go to draw my picture, I know it's a solid. I got to draw a solid line because I see the bar. I'm not going to say which way I shade because it's not solved for y. It's not y is. I don't have it set up to where y is by itself. So right now, the only thing I can say is when I go through to draw this sucker, I can make a solid line, and then I can go from there. So first thing I'm going to do is I'm going to solve this for slope-intercept form. So 2x minus 3y is less than or equal to negative 6. So I'm going to carefully just solve for slope-intercept form. When I divide by a negative, what does it do? Yeah, it flips the symbol. So this becomes greater than or equal to 2/3 x plus 2. So I now have my equation solved for y. And I'm going to grab a xy axis here. And I'm going to, oh crap, that's one big xy axis. There we go. All right, so as I go to graph it, I got a y-intercept of 0, 2. I got a slope is equal to 2/3. So 1, 2, that's my first dot. And a rise of 2, 1, 2, run of 3. There's my other dot. And again, I can keep repeating that if I want to, up 2, over 3, something like that. Now, I did indicate that I could do a solid line, so I'm going to go ahead and draw the solid line. Because we did say that it was supposed to be a solid line. Now I got to figure out my shading. Once I have it solved for y, I can see that this says y is greater. So that means I got to shade above. So that means I'm shading above everything above that line. So I'm indicating that with my arrows. I got to shade everything there. So you don't have to draw in every nook and cranny, but I'm basically, my solution zone is that green zone right there. And remember, it keeps extending. But that lets my reader know that every ordered pair on the blue line is a solution, plus every ordered pair in the green section is a solution. That's what that means. When it was just an equal problem earlier in the semester, just the thing on the blue line were solutions. Now that it's an inequality, everything in a certain zone is a solution, and the ordered pair in a certain zone. So in this case, it's everything that's above that line, since we said it was greater than. Again, you can't decide the greater than or less than, or shading above or below, until y is by itself. That's a good rule of thumb. Okay? Let me hit attendance here real quick for you guys. Am I missing anybody? How many bodies do I have in here? 4, 8, 12, 15. I got everybody. And let me turn down my volume on my speakers because I get emails left and right. All right. Let's do the next one. Now, on B, if x squared and y squared, what picture should I see?
A U.
No.
No, it's a circle.
Thank you. A U is when one of the letters is squared. When both are squared, we got a circle. Okay? So, remember, we have this in our notes several times. X minus h squared plus y minus k squared equals r squared. My center is h comma k, and my radius is r. So in our case, our center, for our purposes here, our center is 0, 0. Because there's no numbers with the x and y. So this is centered at the origin. And my radius is the square root of 9, which is 3. We see 9, but technically it's supposed to be radius squared is what's in the equation. So I got to take the square root of the number they tell me to find my true radius. All right? Now, On a circle problem, let's go ahead and draw our circle. So I'm going to draw an XY axis. Try to get your tick marks evenly spaced out. And now this tells me if I got a circle that's centered at the origin with a radius of 3, that means that I go through all the 3's. And there's my circle. Now, I'm going to go up and change my eraser tool. I'm going to go to a small eraser. Because instead of just re-erase the whole thing. Now, let's go through on this one. We don't have to solve it for y because it'd be too crazy to. So let's indicate what we're going to do. I'm going to do a dashed line. Why am I doing a dashed line here?
Because it doesn't have a line underneath.
Thank you. There's no bar, so that means I got to do dash. So that means I'm going to take my eraser tool and make now there are holes in my circle. So I'm going to make holes in my circle. Okay. So I got a dash circle. And then now the inequality says what? It says y is less than. Okay, y is less than. I know we're not solved for y, but if I did solve that for y, it's still going to stay less than. Because is there a minus sign in front of the y squared? No. So even if I had to solve that for y, I'm not dividing off a negative, so it's not going to change the sign. It's going to still face away from the y. So I can go ahead and say this is less than, which means I need to shade below. So I got to shade below. Well, in this case, shading below means inside the circle. So when I go to shade, I got to do everything inside of 3. So it's everything inside of here. I can't go outside of 3 away. Remember, 3 is our radius.
So if it was the other way, you'd shade everything but inside the circle?
Correct. If we had like greater than 9, then we would shade everything outside the circle. Correct. Okay. So less than typically means, in the case of the circle, inside the circle. If it's greater than the circle, means everything outside of the circle. Parabola is a little bit different. Okay, sometimes. Okay, so as we get the different shapes that aren't linear, we'll talk about cases here. All right. All right. So now we get to practice some more. Oh, 2 equations. Hey, let's skip down here. Let's do one at a time. Let's do some of those. And then we'll come back up here when they say systems. We'll go back up to that. We got plenty of. This is all we're doing today. If you look at what we got there, there's not much there. So this is a lot of practice doing it. So this is where you want to make sure that you're playing along with Mr. Stevens and you're practicing as we go through. So I highlighted some ones for us to do. I got a couple linear functions. I got a circle and I got a parabola for us to do. All right. So let's start off with number 5. And then once we do those 4, if you want me to do any other ones that are listed in that section, let me know. So number 5 says x is greater than or equal to y. Well, that's already solved for y. All right, so it just says it in the reverse order. So with that in mind, what type of line do I get to draw? Solid or dash?
Solid line. Oh, talking about the solid line.
All right, there we go. Now, where do I get the shade? Shade above or below?
Above, because it's great. It's greater than.
Who's the main noun?
It's below. What? Could it be below?
All right. As we decide, it's always what's in relation to y. Is that thing opening up towards the y or away from the y?
Away from.
Away, so we should be shading below. We always pronounce it as y is what? In this case, y is less than or equal to x. It doesn't matter that it opens up to the x. All right, when we go to pronounce for graphing, we get into slope-intercept form. It's not x equals, it's y equals slope-intercept form. So we got it, y is the main subject of the problem. So as we look at it, y is less than x. So that means I got a less than means I go through and then shade below. So with that in mind, if I go to graph, draw an XY axis. Now, on this one, what's my origin? Or wait, what's the origin? Is it my x-intercept?
It's the origin.
Yeah, the origin. Where's the origin?
Wait, why can I not think about what the word is?
Okay.
Where the lines cross.
Thank you. So the origin is right here. The origin is the x and y intercept for this problem. Because if it's y is less than or equal to x, that means that it has a y-intercept of 0, 0. And I have a slope of what?
1.
1. So that means I have a nice perfect diagonal line that splits the first and third quadrants. Now, we get to do a solid line, which means all I did was draw like dots to indicate the rise 1, run to slope of 1. Rise over run stuff. So now I get to make that a solid line, because we said that it gets to be a solid line. And then we get to indicate that we are shading below it. Well, below it would be technically below it. It would be the stuff that's in this zone down here, this stuff. That's below the line. So that means everything here gets to be shaded. And I like using the arrows just because when we start doing more than one equation on the same graph, we start shading where they point to the same zone. Okay? So that's why I have the arrows there, is because I'm going to use that in the next section of stuff today to teach. All right. Number 7. Number 7 says x is less than 1. All right. We'll go beach colors on this one. Blue axis, orange stuff. All right, x is less than 1.
1 is the y, right?
No, there's no y there.
Oh, no.
If you only have one letter in the problem, what type of line is it?
A straight line.
Good. Boy, there's several straight lines out there.
It's vertical.
Right, this means I have a vertical line because x is the only letter there. So that means I have a vertical line, and I'm going to say it's vertical and it's dashed. Why do I get to say dashed?
Because it does not have the line.
All right, good. There's no bar. There's no bar on there. So at 1, so as I switch over to orange, at x is 1, I have a dashed line. So there's my dashed line. And then this is saying x is less than. So that means I have to do everything to the left of the line. So that means I get to shade this stuff here. So that's my shaded zone. Everything to the left of that line. So in this case, any ordered pair in the shaded zone is a solution. I cannot use any ordered pair on that line. Any ordered pair that starts with a 1 comma something is not a solution because I don't have that equal to bar on there. Bless you. Now for the diagonal lines, a lot of times what you can do, if you're not sure, what's above and below, is turn your head according to the slope. So like for example, on the first one, I got a slope that's positive, so I turn my head this way. That's above, that's below. Okay, so, All right, now let's do number 14. 14 is x squared plus y squared less than or equal to 1. So as I go to graph this one, my center is 0, 0. My radius is 1. Because the square root of 1 is 1. So with that in mind, I put a tick mark out each direction. And then I get to draw my circle. And then now, and again, a circle will always have a plus sign in front of the y. Okay? A circle will always have a plus sign in front of the y. So we should be able to distinguish here and say solid line, shade, inside circle. At our level of mathematics, we will never have a negative in front of the y squared. Other courses in math we could, but not this course. So I get the shade inside, so everything inside the circle. So this one tells me any ordered pair that's in the circle and on the outer edge are solutions. That's what that tells me. Whereas the first circle we drew, it had a dashed circle line. So that tells me only the ordered pairs inside the circle were solutions, whereas circles on the perimeter were not solutions. All right, number 15, we got a parabola. We have x squared plus y is less or equal to 2. All right, so let's go ahead and solve this for y. So y is less than or equal to negative x squared plus 2. I'm going to go ahead and make a note what I'm doing here. Solid line and shade below. So as I draw my picture, what's my vertex of my parabola? It'd be 0, 2.
Yes.
And how does this thing open?
Downward because the x is negative.
Yeah.
Okay, so with that in mind, at 0, 2, I open down. And then now, again, I said I had a solid line, so I went ahead and drew a solid parabola. Now it said everything below the parabola. So that would be everything inside the center here. That'd be all this stuff here. That is technically below. Now, here's the other option. Now that I've done 6 problems this way. And this is what an option your book gives you. You can do this option if you want. Test 0, 0. If 0, 0 is a true statement, then shade the zone that includes 0, 0. If false statement, then shade other zone. Shade the zone that does not include 0, 0. Okay. So if you don't like the indicating method that I showed with the greater than means above and all that stuff, what you can do is you can test the point 0, 0. Okay. If you end up getting a true statement where when you put in the numbers, it's like, oh yeah, that's true, 5 is less than 10. then we get to shade where 0, 0 is. If I get a false statement like 5 is greater than 10, then I shade the zone that doesn't include 0, 0. All right, so that's an alternate method that you can do. The only challenge is on a linear function, does your line go through 0, 0? Because we had one that did. We had that x is greater than or equal to y equation. There I can't test 0, 0 because 0, 0 is actually where the physical line is. So knowing does it a false statement or not doesn't help me. So then in that case you'd pick like 1, 1 or pick something else. Pick something that looks like it's not on that line, and then pick another ordered pair that's nice and easy. Test that point. If you get a true statement, you shade where that point is. If you get a false statement, you shade the other side. Okay, so again, those are your options. You choose what you want to do. Okay. All right. Now let's scooch back and let's do that. And Mr. Stevens is going to go there. Can I go here? Oh yeah. See, I'm so smart. I'm gonna move that up. I got so I don't want to make it taller. Just need to shift you. There we go. Give myself some more space. All right. So now what happens when we have a system of inequalities, whether in this case we got linear and nonlinear? So what happens if we're dealing with two things? First, again, the first thing you're going to go through and do for steps, graph both functions with appropriate type of line. So again, dashed or solid. Two, this is the way I always do it, is indicate with arrows what should be shaded for each line. 3, only shade the zone that has arrows pointing from both equations to it. I'm going to put a little note here. You could test 0, 0. If you wanted to, you could test 0, 0, but you're going to have to test 0, 0 in both things. It'd have to be true for both for you to shade that section there. So I always, again, the way I've been teaching it since '94 is always like, hey, I point this way, point that way. Where am I pointing to the same section? That's the only part that gets shaded and stuff. So that's the way I've been teaching it for 30 years. Again, you could test 0, 0. You just got to make sure you test 0, 0 in both equations, and it's got to be true for both. Okay, if you like the testing 0, and I would suggest try testing 0, 0 a couple times to see if you like that method. Okay, you're not Again, when you're showing me work for this kind of stuff, You know, if I see you put 0, 0 in there and you show me that it's, you know, true for both, and then you shade the appropriate area where 0, 0 is, that's enough work for me. If you want to indicate with the shade above the arrows like I'm getting ready to show you, that's fine too. Does anybody need my notes like that still? I know I wrote a lot down there, so it's kind of tough to keep up with, so I didn't want to get it off it too quick. All right, so let's practice the one on the left. Let's practice A. So the first one is already solved. The second one, I'm going to go ahead and, you know, bring the x over. So I have y is less than negative x plus 4. That's one of the equations. Y is greater than x squared is the other one. And then I'm going to indicate with the parabola, shade above dashed parabola. And then on the other one, I'm going to indicate that I'm going to shade below a dashed line. So I just made a couple little notes here real quickly. What type of line I need to draw for each one of them. They both end up needing to be dashed. One I get the shade above, the other one I get the shade below. All right, so drawing pictures. Y is greater than x squared. That's a parabola that has a vertex at the origin. Goes through 1, 1, negative 1, 1. It'd be 2, 4, negative 2, 4. Dash parabola. Dash, 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 dash. All right, so there's my dash parabola. I need to shade above it. So that means the inside in this case. So shading above would mean that I'm doing everything inside. So I'm going to indicate arrows all the way around just because I don't know where these two things are going to cross, is what I don't know. So now I'm going to go ahead and do the other one. The other one says I have a y-intercept of 0, 4 and a slope of negative 1. So I start at 4, go down 1 over 1, so that means eventually I'll cross at 4, 0, and then I'm going to draw my dashed line through that one. And then they want me to do everything below that line. So I indicate below as follows. And so my shaded zone, my solution zone is the zone that they point to the same area. So the only area where it shows that it's pointing to the same is what I'm highlighting in yellow. That's the shaded zone. That's the solution zone. That's my solution zone. It's the only zone where it's having purple arrows, and in case purple arrows that I use and blue arrows that I use indicate that it's pointing to the same section. Now, how can we check to see if I did this right? I could do the 0, 0. I could put 0 into both things. So with that in mind, if I put 0, 0, if I put 0, 0 in the original, is 0 greater than 0? 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 It's not greater than it's equal to it. Okay. That's why it's hard to use it on that one. But so in that case, maybe I should use maybe 0, 1. If I use the point 0, 1, because I see that it's in the shaded zone. Then is 1 greater than 0?
Yes.
Yes. Then over here, if I do the same point, 0, 1, 0 plus 1, are you less than 4?
Yes.
Yes, so I know that's the right zone. Okay, because it came true for both. Okay? So, unfortunately, 0 would have been fine. 0, 0 would have been fine for the second function. It just didn't help us out on the first one. So, in other words, if you want to test, did I do it right? Pick one of the points that's nicely in there. Test that point. Should be true for both. Okay? If it's I would always double check my math, but it gets a little bit trickier on the calculator doing things. As you're trying to get the calculator to graph inequalities, but you can get them to graph inequalities. Like for example, if I typed in x squared and I typed in negative x plus 4. And then what we do to go to inequalities, we go back to highlight, like I have it highlight, flash it on the red and the line there. And I want to say, it's not the arrow keys. I think it's pressing enter. There we go. And then I can go down here and choose, what do I want to do? Shade above, shade below. There's a dash line. So in this case, we wanted to shade below that line. And then hit OK. And then I want to shade above this one. So as I press enter, and then change that to be above. So that would be, above. So below and above, I hit graph, and then I can see where they overlap. So here, notice how much is shaded. But the only true solution zone is, what do we know when red and blue overlap? We see what color? Purple. All right, so this is this purplish as they got here, so this is my solution zone here. So you can use technology to do it. Desmos does a better job of showing the distinction of, hey, that's truly a purple zone, and stuff when it picks the two colors. And you can choose your colors, like, what does blue and yellow make? Anybody remember what blue and yellow makes?
Green.
Thank you. Makes green. Okay, makes green. All right, let's do B. Again, you can, as we go through, let's see B. We want to solve them both for y. So x plus 3y less than or equal to 9. Sorry.
What did you click on the calculator to make it look like that?
I went back. You arrow to the left of the y equals, and then you press enter, and then you can go down and choose what type of shading you want. You can tell it to do a dash line, but it's just so hard to see on there. But at least you can shade above and below, is what you can do. So. All right, so there's the first one. The second, Mr. Stevens. The second one, if I have 2x minus y less than or equal to negative 1, negative y is less than or equal to negative 2x minus 1 divided by negative 1. Flip over, y greater than or equal to 2x plus 1. So both lines are solid lines. And then I'm solid line, shade below on the blue one. On the red one, we are solid line, shade above. So I made my little notes as I get ready to draw now the picture. Shade below that line. So there's shading below the first line. The second line, start at the 0, 1, slope of 2. Again, solid line. And this one was shade above. So what's the only section they point to the same exact location? Bless you. That section right there. So there's my solution zone. That's my solution zone. Could you test 0, 0 on this one?
No,
I could.
it wouldn't work.
It wouldn't help me though, right? Because how many potential zones could we shape here?
4.
Yeah, there's 4 potential zones. Only isolating 0, 0 indicates one zone I can't shape. So here, once you get it done, then I would pick a nice order pair that's in your zone that you think it is, and then test that point to see if it should be that or not. So like to me, picking any ordered pair on the x-axis here would be a good one to test. And then if it was true for both, then you know, hey, I shaded the right zone. Okay. If it's false, then I got to try to pick an ordered pair in one of the other zones to see if I should shade that zone. Okay. So, but that's how you can go about it. You can always test a point. It's just, you know, I think indicating with the arrows, and the only way you can indicate with the arrows is if you got y by itself, unless it's a circle. Circles you don't have to solve for y. Okay. Because I'll never have a negative in front of it. Okay. All right. Let's try, in the remaining minutes we have, let's do 36. And let's do 40. Let's do those. You want me to give you a head start on those?
Yes.
Okay. Again, lines we're able to type into the TI-84. Circles, it's hard. So that's why we need to make sure we can do the circle ones as well. Because you may have one on your test. All right, so there's number 36 for you. A little bit different because of the way that second line slope was. You okay, bud?
How is that one upwards?
Well, I move the.
Oh, you move it over, then you have to also, yeah.
If you move the x squared, then you'd have to divide off a negative.
Yeah, I just missed one of the stuff.
You're fine. So the square root of 6 is like 2.4-ish. So about almost 2.5. So when you go to draw your circle on the next one, you're going a little bit outside the 2's. We have to do a solid circle, so solid circle, and inside it, inside. So that's inside. And the only place that lines up would be right there. There's my solution zone.